Camera, hello.
Time lapse would have been catastrophic because then I'd have no sound. So I had to sit there and do the proportions to figure out how fast I needed to speed the video up to get it to be normal. So, what is our ratio for sine? Opposite over hypotenuse. How about our cosine? How about our tangent? Anybody know these three guys? Nope. All right, let's start by here. I gave you their definition in relation to their positioning on the sides of a triangle. So here, sine would be, here's theta, opposite over the hypotenuse. We'll solve for that in a minute. But this would be 4 over 5. This would be 3 over 5. This would be 4 over 3, just from that red triangle. Has anybody ever seen cosecant before? Yeah. Perfect. So I wrote these so that they're in an associated fashion. Sine and cosecant go together. Cosine and secant go together. Tangent and cotangent go together. Cosecant is just equal to 1 over sine theta, which then, well, let's do that in just a minute. This is 1 over cosine theta. I'm going to show you how to find adjacent in just a second, because they change based on where theta is. So, if I look at these algebraically, 1 over sine theta, this would be 1 over OH, O over H. Now, if I evaluate, Josh, question?
What is theta?
Theta is our angles measure in radians or degrees right here. This is just, instead of x, we're going to use theta in this class for our angles.
Is that always going to be there?
Nope, so it could also be up here. Technically it could be here, we're not going to really see that too much, but theta can be in any of these spots. This is just our new variable that we're going to be using. How would I evaluate this right here? This is just a complex fraction from algebra 2, right? Yeah. So, this is the same as 1 over 1 for my numerator here, over this. And to do that, I'm going to keep, change this to multiplication, and flip this. What is 1 times h? What is 1 times o? So my cosecant is the hypotenuse over the opposite. So look what we named these identities. They're reciprocal identities, right? Is this not the reciprocal of that? Don't waste your time with that anymore. Yes? That's exactly, yeah, so what would secant be? Go back to cosine. It would be h over a. And then, what's our last one? Adjacent over opposite. So those 6 are really important to know. There's actually a lot more. There's hyperbolic, sine, cosine, and all that. So we're already up to 12 just adding that in there. You're not doing hyperbolic in this class, but it's good to know it's coming. Now, any questions on those? No. So here we said sine was 3 over 5. Gavin, how did I know this was a 5 here?
3, 4, 5, right?
Yeah, it's a Pythagorean triple. A squared plus b squared, 9 plus 16 is equal to c squared. 9 plus 16 is 25, square root of that is 5. I chose a nice Pythagorean triple for you. So if the sine is 3 over 5, what's the cosecant? Yeah, you just flip it upside down. Drawing a blank on names that I don't normally call. Joey, what would you get for the cosine here? 3 over 5. Oh man, did I really just mess that up? Yeah, it's 4 over 5 here, isn't it? Thank you, Joey. If I flip it, I get 5 over 4. Now, somebody asked, how do we know which one's the adjacent? And I probably should have answered that first before I made that mistake. when I'm looking at my angle, there's three things that can be opposite, adjacent, or hypotenuse. And I'm going to show you exactly where my brain just failed. Looking at this, what's opposite of that angle? Or this angle generates which side? That's 4. Now I'm going to skip adjacent for right now because we always know the hypotenuse is opposite of the 90 degrees. And then we only have one thing left, and that has to be the adjacent. So that's going to be 3. Now let's double check that I made my mistake. Opposite is 4, hypotenuse is 5. Flip it for 5, 4. Now, here I want adjacent, which is 3, and my hypotenuse is 5. So while you're getting used to this, and I should have done, label these so that you know opposite, hypotenuse, and what's left over is always your adjacent. So for the last one, adjacent over opposite, what would I end up with? 3/4. So what would that make tangent then? And what was this one again, Anirudh? 3/5. All right. So all these do need to be committed to memory.
So then, for the cosecant and stuff, what will they find
Say that again.
on the triangle?
Say that one more time.
So what would the 3 new ones that we learned, what would they like find on the triangle?
He has a good question there. Anirudh asked, you want to look at the cosecant, right? It's still 5/4. So maybe I don't have all the information I need on the triangle, and I would just need those. Because if I can tell you that the cotangent is 4/3, let's say that's the only piece of information I gave you. Let's erase all of this and see if we can rebuild this triangle. All right, Anirudh asked, what are these useful for? What if this is the only ratio you were given? Which one do you want to use, cosecant, secant, or cotangent, Anirudh? Anirudh says, what if all I was given is the cotangent of theta is equal to 3/4? Well, I know the cotangent is equal to the adjacent over the opposite. So looking at theta, opposite is 4, and the adjacent is 3, and now I can just do the Pythagorean theorem to find the rest. That's really what we're doing with these for now. It just gives you everything you need to find that triangle. Mo?
If theta was in a different form, how would that change the whole thing?
Yes, it would. Yes, sir. Yep. And that's kind of what I was going to get to here, is these are both 30, 60, 90 triangles, right? The smallest angle generates the smallest side. So here, this is the smallest side, but here, this is. So we do have to be aware of where they're at. And that's why our unit circle has 3 distinct lines in every quadrant. We're looking at the 45, 45, 90, and then both orientations of this triangle. And then when we put them all together, you'll get those 3 distinct lines between each quadrant. So that's a real, yeah. Huh? Which ones? So these are just your trigonometric identities. These 3 are called your reciprocal identities because they're just the reciprocal of this. We're going to learn the quotient identities. Then we're going to go to the Pythagorean identities. Then we're going to do those 2 triangles, and we're pretty much done with 4.3 then. So, quotient identities are a little funny. I'm going to erase this, and I'm going to come back and ask you something. Could we express tangent as a ratio of 2 trigonometric functions? That's a weird question for now, I think. What we're going to try and do is show that tangent is equal to the ratio of the other 2 functions here, and cotangent is the ratio of these 2. And you can kind of see here that because these are the same, if I were to divide them, what would happen? This would flip and the 5s would cancel. But let's look at that. So if sine, we're going to do this in 2 charts. We have sine theta is equal to the opposite over the hypotenuse. And we have cosine theta is equal to the adjacent over the hypotenuse. What's going to happen here if I put sine, what is sine divided by cosine as far as these are concerned? Right? Now we're going to do this. Keep it. Change this to multiplication. Flip this. And what am I left with? O over ha. And what is my tangent? Oh, it's just O over A. So we can also add here that tangent, theta, is equal to sine theta divided by cosine theta. Now, very upfront about my failures going through all my math classes. When I took my trig class at HCC, I failed this test. I got a 37 on it after test corrections. Then he let me retake it, and I got a 54. And then we agreed that's where I was going to stop because my other grades were good. These types of verifying identities was the hardest part for me. So we're going to have this on the test, but I'm going to give you a lot of examples here. But before I do that, just knowing that cotangent is the reciprocal identity of tangent, what do you think cotangent's going to break down to in terms of trigonometric ratios? Yeah, cosine. In the numerator or denominator? Yep. And what goes in my denominator? This one? Sine.
No, the SEC theta.
Where does the SEC come from? Remember, cotangent is just 1 over tangent.
Yes.
Tangent, sine over cosine.
How do you pronounce it?
This one?
No, the other one, the middle one.
Secant.
Secant.
Where does the secant arrive from here?
It's 1 over.
Do we have 1 over cosine here? So would it change? It's literally just the reciprocal. So if I have tangent, I can just flip it upside down to get cotangent. And if you look here, 4/3 flipped is just 3/4. So those are your quotient identities. You need those because when we get to our Pythagorean identity next, we have to be able to change and manipulate all this. We're going to start getting secant squared out of stuff. We're going to get cosecant squared plus something equals something else. We're going to end up with tan x times secant x is something. And then next year, if you take calc, you're going to be doing derivatives with all of these. So, the derivatives are actually easier than you think. So, any questions about how I went from sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, to tangent is just sine divided by cosine?
Is that just like a parent?
You can think of it as a parent function, yeah.
Okay, so like,
They may not. You may have to construct a triangle. I know. There's a lot of stuff that's going to happen in this chapter where your eyes are probably going to get stuck to the back. Yeah, when you keep rolling.
for right now, you're giving us the triangle.
On the test is going to look almost exactly like your review. I'm just changing the numbers. That's it. So what you see on the review is what you can expect on test day. On your review.
So can cotangent also be equal to secant and cosecant?
All right, we had a question here. That's a really good question. On your route, say that one more time.
Can cotangent also be equal to secant or cosecant?
Over what?
Over cosecant.
What do you guys think about Anirudh's question? Is that true? Let's find out. Oh, you wanted secant and cosecant?
Yes.
Oh, yeah, then you were 100% right. I heard cosine the first time. That's where I was hung up. That's why I wrote it first, and then I was saying. Sydney was, okay, Anirudh. It's like Leibniz and Newton here. You just stole the idea for this. Sorry. Josh? Can I actually show you this one? Yeah. But let's look at this one. This one is the same as, oh, I'm going to run out of room. This is 1 over cosine, right? This is 1 over secant. Keep, change, flip tells me I'm going to end up with, oh wait, 1 over sine, guys. What's that going to evaluate to? That's going to be sine over cosine, so what would it actually be, Anirudh? Tangent.
Yeah.
Not cotangent though, right? But you did say cotangent.
Oh, yeah.
Okay, so for this one, when we do this, we're going to end up with sine
Oh, yeah.
over cosine. This right here is exactly where I failed this test, is stuff like that. So you're right, it's just the reciprocal identities reciprocated go back to here. So then what would cosine over sine be? Well, that's why it's cotangent. Or sorry, cosecant.
What about, instead of CSC theta over secant theta?
So you want to do these two now?
Yeah.
Let's do it. Josh?
So there's not a third quotient.
Nope, it's just these two. Let's do that last one, and then let's look at the Pythagorean. Now, I really appreciate that you guys are asking these questions, because this is what the Pythagorean identity tells us. We can find all of these. Sydney, one more time, just so I get it right. It was cosecant over secant?
Yes.
Do you have a prediction as to what this is going to equal when we're done? Anybody want to throw out what their instincts are telling them that's going to end up being? Josh? Cosine. So, cosecant is 1 over sine theta. And secant is 1 over cosine. And I think we're just kind of spinning our wheels here. Where are we right back to, guys? Cosine over sine, which is cotangent. Anirudh, that's the one you wanted, sir. This one is going to be on the wall? Not yet. Up next to my laptop. All right, so let's move into the Pythagorean identities. These two are kind of extra. The fact that you guys had questions and we got this far into it is pretty impressive. Is it okay to erase this? I don't think anybody should need it anymore. Yeah, every identity up here is definitely going to have to be memorized for this class, AP Calc, and beyond. But I'm trying to show you in a way that, like, if you memorize these three, which most of you should already have from geometry, the reciprocals, and the way I remember them, the reciprocal identities all have a C in them, right? Cosecant, secant. This one starts with a C, but the one it doesn't, it's the oddball, right? S to C, C to S, and then T to C. Not the best way. I honestly remember them as long as I can keep this in my mind, the word cosec, that's cosine goes to secant, and then from there, you can't really mess up tangent to cotangent, and then that forces you to have sine and cosecant. If you have a better way to remember it, please give it to me, because I know that's pretty bad, but it worked for me. So, let's look at the Pythagorean identities. Before I do that, what's the Pythagorean formula? Ethan? What's the Pythagorean theorem? I'll give you the head start. Perfect. Now, on a units, well, let's not even do that. What if I had this triangle? This would be my x value, right? This would be my y value. We agree on that? Whatever the length of this is x, whatever the length of this is y. Could I also rewrite then as x squared plus y squared equals c squared? Wouldn't this just be c? Pretty easy, right? I should have put y first, but the Pythagorean identity, separate from this and by definition, is this. Now, it's equal to 1 because we're on the unit circle and our radius is 1. And again, see, if I drew a circle around this this could just be my radius of the circle, right? So now we have something interesting happening. If this is theta, this is now opposite, right? This is now, y is my sine value, x is my cosine value, and this is my radius. So, sine can be expressed as y over r. Cosine can be expressed as x over r. What would tangent be? Y over x. Now, we're going to get more into this in 4.2, but I want to show it to you ahead of time. Does it matter which order we add stuff? No, right? Especially since it can't be negative. So this one goes here, this one goes here, and we're limiting our radius to 1, and that is the whole basis of this class, is that this number will always be 1, just like I promised over there. So, what if I took this and I divided everything by sine squared on this part right here? What would I end up with? Go ahead. You muttered so many great questions today. Ask them out loud.
Oh, me?
Yeah, every time I hear you mutter something, I just answer it, even if you...
I always wonder, like, why is there an R?
Oh, okay. Right here?
There's C, yeah.
That's the Pythagorean Theorem.
Yeah.
I'm adjusting the Pythagorean Theorem to be the x, the y, and then still a c, right? It's a right triangle, and you would agree that's c.
Yeah.
But if I drew a circle around it, isn't this then the radius of that circle?
Yeah.
No, right? You don't see it. You can say I don't see it. What am I going to do? Throw you out of the class? All right, let's try this. If this is the center, right?
Oh, yeah.
That's the radius, right? Now, if this is my x and my y, don't I have that same representation here and there? So I changed my c to an r because that's the radius of a circumscribed circle. Perfect. This is what I say. Ask them out loud. Now, let me erase some of this mess, and we're going to take, Sydney?
So if we're talking about like circle on like a graph, and there's like it has graph paper, then could you say that the x and y axis to the line of the circle would be 1 since the radius of the circle is always 1?
Yep. And then just come over here real quick, Sydney, so I can show you this, just because you asked a really good question, and I want to show it to you fully constructed. Look at the coordinates at each of the quadrants. 1, 0, 0, 1, negative 1, 0, 0, negative 1. That's exactly it. And then as this swings, obviously the radius is still 1, but the right triangle that we would build can't be a length of 1 because it won't quite make that little bit left. That's what we're finding now. Makes sense? That's the only reason I asked you to come over here, just so I could show you it that
But
way.
like if there's like excuse me, I'm
Yeah,
not
go
this
ahead.
tall.
Yeah, you're good.
There and there,
Yep.
and it doesn't have labels. Could we assume that the length of the x-axis from here, if this is 0,
Yep.
I'm like on my tippy, but this down to here
Will always be 0 and then, yeah, negative 1. Yeah. One,
Yeah, well,
well, the
I can't
magnitude
reach
would be
up.
1. I know. Yeah,
Okay.
it would have a length of 1. That's by definition. That's why we define the radius to be 1.
Okay, perfect.
Only because you had that insight. We're learning that next class, but I don't want to leave you hanging. You're welcome. All right, let's talk about this right here. Oh, no, I was saying for the whole class. Let's look at this one. No, I'm sorry, Sydney. So, right here, there's a ton of Pythagorean identities, and we have to find them all basically on our own. If you can memorize this one, it's a squared plus b squared equals c squared, y squared plus x squared equals 1. I can do a lot of stuff here to find a lot of these other relationships. Like here, I'm going to divide everything by sine squared theta. What is going to be sine squared theta divided by sine squared theta? Josh, what do you think? If I take this value and I divide it by itself, what am I always going to get?
1.
Perfect. Josh, pick somebody. Anirudh. Now I have cosine squared theta divided by sine squared theta. What is cosine over sine equal to over here? Oh, I erased it, didn't I? What was it in your notes? What's cosine over sine?
It's the cosine.
That's 1 over sine. This was a quotient identity. This is why we had to name these two. What was cosine?
Well, that's cosine.
Anirudh saying this is cotangent. Do we agree? So now I'm going to have 1 plus cotangent squared theta. Anirudh, I see what you did. You were giving me this answer. Anirudh, pick somebody to give me the answer. They'll steal your work. Who is it?
Gavin.
Who?
Gavin.
Oh, Gavin. Gavin, what does 1 over sine equal over here? Yeah, we're going to call it cosecant. Yeah, this one, right? So 1 over sine is just cosecant squared theta. This is another Pythagorean identity that you will need to put to memory. You're going to have to manipulate all of these. Now, what I'm going to say, ooh, I just smacked the microphone, sorry if you're watching the video. What I'm going to say is, as long as you have this one committed to memory, you can derive the rest relatively simply. Josh?
So what in this case is equal to cosecant theta?
Here? Yeah, when I divide by sine, it's going to leave me with cosecant because 1 over sine is cosecant. Now, I kind of like Josh's reasoning here. Let me ask you this. I've done this work to get these 3 values. What is cotangent squared theta equal to then? And it might be a confusing question, but it's the easiest thing we can do. What's on the left-hand side? It's 1 plus cotangent, right? How do I move the 1 over? There you go. Now you know what cotangent is equal to. So now you already have 3 of your Pythagorean identities. There's many more. What I want you guys to try really quick on your own is instead of dividing by sine, take this original and divide by cosine. In about 4 minutes, I'll do it with you guys, but I want you guys talking about it and getting it done. Callie, what's up?
I go to the bathroom.
You may go to the bathroom, yes. Yes.
Where's the cosine divided by sine squared?
It comes from right here. So I have to do each of these values divided by sine. And then as far as...
them separately?
Yes, yep, break them down separately.
Oh, so sine squared, that's...
Yeah, I see, like this is one, yeah, perfect. All right. Group 2 asked the best questions, but they're so quiet. Suraj, what are you going to get if you divide by cosine? Yeah, do this again. Let me write it down. Kayla, I'm on my way, I promise. Now divide all of this by cosine squared theta and see what you get instead.
I'm confused with all of that.
The whole mess, right?
Just the last part.
The very, when I went from,
When you divided it.
so starting on y, yeah. So is the confusion part because you don't know why I chose to divide by sine? That was an arbitrary decision. I just wanted to start with that. I'm just saying, let's see what happens when I do something. Sydney? Give me 1 second. Let me finish Kayla's and then I'll be right there.
I thought she was.
We got step 1 out of maybe 3. So because I chose that, what I now need to do is here's the Pythagorean identity. And I said, just divide by sine, just because that's, you know, kind of an intro that everyone sees the first time. And then it becomes what is basically, it breaks down to this for us. Right, because I divide each term by sine squared. This divided by itself is going to be 1. Then I look at I have cosine over sine. That's a quotient identity. Which one is it though? I erased it off the board, I'm sorry. Kind of got overzealous in it. Okay, cosine on top, sine on the bottom. Perfect. Still squared. And then what is 1 over sine squared? And that is the answer. The only other thing I asked is, could we solve for just this by subtracting 1? But right now, well, try this, but instead of sine squared, try it with cosine squared while I talk to Sydney, and then I'll come right back to you. Well, I'll be right there. What's up?
I was able to cancel out cosine, but then sine over cos is
10, yep.
So would this be equal to 9?
only thing you got mixed up is 1 over cosine is, there you go, and that's the answer. Now, what if you wanted to solve for tangent squared theta? Say it again?
Yeah, it's still squared, right?
Always squared, yep. Feel good?
What was your question?
How would you solve for tan squared theta now?
This?
Yep.
Would you just divide by tan squared theta?
No, if I want to isolate that, what would I do to isolate it?
Add.
How if I had, what if I had, let's go back to like here, what if I had, what if I wanted to get x by itself, what would I do? There you go. Is that the same, this is that? Yeah, there you go. I just want to make sure you see, you can also jump into that next step. Kayla, I'll be back after Mo. Anirudh, what's up? Okay, so it's gonna go Mo, Kayla, and then I'll be there.
So we already went over this.
Yes, sir.
And then there's also this, right?
You can do, yeah, if you want to do all that, Mo, yeah.
Then, okay, so this is what I'm wondering. How come for for tangent, you can use these two to find,
Any of them, yep.
and then for like cosine, you can use sine and tangent. But then how come for sine, you have to use tangent and secant instead of tangent and cosine?
You're saying, let's write it down so we can look at it together. Sorry. What was the setup here? Which function goes on the left for the we're setting it equal? You wanted what?
I'm wondering why for
Sine
sine,
theta is equal to.
tangent over secant.
Now, from playing with this, are you saying this is the only way to get sine back?
Probably not. I'm saying how come we can't use cosine and tangent
To get,
sine?
so let's try so you want a counter example. You said cosine tangent, right? How would you approach this?
Because I did this one like tangent.
Oh, actually, I think you found a different identity. Let me just say this. This is cosine theta over sine cosine, right? Keep change flip. This is going to be cosine squared theta over sine theta. You're starting to approach your double angle identities.
I was doing this one because it was O over A times the reciprocal secant, which is A over H, which would get you sine. But if you did, like, just without this, if you just did cosine over tangent, you'd get A over H times A over, and that wouldn't really cancel out. But that would get you A squared, which is weird.
Is that true?
What?
Is this statement true? I'm going to go to Kayla real quick just to check on her. See if this is true, and now you're going to start seeing why these get so complicated. Do you agree that tangent is this is equal to that? And I'll be right back. Kayla, did you get it? What'd you get? Yes, of course. If you don't mind posting it to Esby too, that'd be awesome. What'd you get, Kayla? Tan squared plus 1. That's it? Is that a little easier once you see it? Yeah, perfect. Anirudh, let me see yours before you pack up. Couldn't have done it better myself. That's it. Guys, please don't forget your phones.